Quad-Lock continues to be the most versatile insulating concrete forming system on the market today. Quad-Lock's flagship panel is the 3 1/8 inch Ultra Panel. A pair of Ultra Panels delivers an effective thermal value of R28. Like all Quad-Lock ICF panels, tie placement is marked every 12 inches by an easy-to-see groove in the EPS. Lighter scores make cutting quick and easy, often without using a tape measure. For today's high-performance buildings, the 4 1/4 inch Plus panel and the 4-inch Extra panel create added layers of insulation, meeting and exceeding building code requirements in all climate zones and even zero-energy building designs. Quad-Lock ties are available in 6 standard lengths, plus a 12-inch extender tie. Depending on the panel combination, wall cavities of up to 14 inches are possible with one tie selection. Wider cavities or thicker insulation layers can be formed by combining any of the standard ties with an extender tie. Ties straddle the vertical joints of all panels. They are aligned vertically and horizontally every 12 inches. Metal corner brackets allow for the quick assembly of 90-degree corners and T-walls and eliminate any external corner bracing. T-wall connections are formed by overlapping the large 90-degree brackets at the top of the T and reinforcing them with tie flanges. The larger bracket also comes in an articulating version that will adapt to any desired angle. Quad-Lock recommends that the following tools be available at the job site: 12-inch sliding compound miter saw, 10-inch portable table saw, extendable utility knives, cordless impact drivers and bits, measuring tapes, both 25-foot and 100-foot, aggressive toothed hand saws for cutting EPS, pruning shears for cutting ties, rebar cutter bender, 6-foot level, circular power saw, metal shears, concrete drill or PAT nail gun for fastening track, and personal protection equipment. Good preparation and job site organization are key to an efficient and high-quality build. Footings poured to within 1/4 inch of level will make the job much easier. When pouring footings, trowel the edges smooth where track will be laid. Clean excess concrete from around cleats that may obstruct the track. Use a laser level to confirm accuracy of the footings. Note variation on the footing with a felt pen or crayon. Ensure that footing dowels are installed per plan. Dedicate 1 or 2 crew members to pre-assemble forms or buckouts for all door and window openings, while others clear excess building materials and debris from the ICF assembly area. Mark the exact position of each window and door opening on the footing and note the sill height for installation. Minimize assembly time by pre-positioning corner brackets and pre-bent corner rebar at each corner, and pre-cut horizontal rebar positioned along the footing. Place panels and ties within easy reach around the entire build area. Set up a cutting station in the center of the build where a dedicated crew member can supply cut panels to others as needed. Note exact wall elevations and plan how to achieve them with ICF panels by cutting the first or last course to shorter height. For example, a 9-foot 3-inch finished wall can begin with a Quad-Lock panel ripped to 3 inches. Pre-plan access points for utilities and services. Install sleeves through walls where necessary prior to pouring concrete. Make sure that bracing equipment is on site or ensure there is adequate lumber on hand if wood bracing is needed. After the exterior building line is snapped, pre-positioned lengths of metal track along the entire footing for 2 rows of track. The Quadlock 2 1/4 inch J-track works for the 3 1/8 inch Ultra panel, which features a groove both top and bottom to fit the 2 1/4 inch track, providing added stability to the Ultra panel. Place the outside track on the building line with the short leg of the J-track facing the interior. Track need not overlap at corners and can be held back an inch or so. Using a PAT nail gun or the drill and pin method, fasten track to the footing at each end and every 24 inches in between. Pre-drilled holes in the track indicate maximum spacing. Double check all fastening when finished. Cut wood spacers to correctly position the inside track apart from the outside track. Lay the inside track against the spacers and secure to footing. See Section 5 of the Quadlock Basic Installation Guide for a table showing correct spacing size for each cavity. Set door buckouts into position. Begin by nailing a spacer at the bottom to maintain the exact rough opening size. Add vertical and horizontal bracing at about 2-foot spacing. Check for plumb and level, then securely brace into position. This video focuses on basic corner construction technique using the R28 Ultra panel. For other panel or R-value combinations, consult the Quadlock installation manual for details. All corners should be installed first. While other forming methods may call for building into the corners, the design and precise layout of the Quadlock system is best suited for building from the corners to a common seam in the middle of the wall. Start with an Ultra corner panel and an Ultra straight panel to form the outside of the corner. Standing inside the corner, the Ultra corner panel on the left overlaps the Ultra straight panel as shown here. Install the 2 inner panels by cutting the mating ends closest to the corner of 2 Ultra straight panels by the cavity size plus 4 inches. In this example, the cavity size is 8 inches, which means a 12-inch cut for each panel. These offcut pieces will be used in the next course. Place the 2 inside panels so that the panel ends away from the corner are aligned with the outside panel ends. This allows both joints to be covered by one plastic tie. Fit an outside corner bracket over the interlock knobs of the 2 outside panels. Place an inside corner bracket over the intersection of the 2 inside panels. Insert full ties as close as possible to the inside corner with both flanges in the outside corner bracket. Cut flanges from full ties as shown here, then insert into outside panel slots starting from the outside corner. Be certain to complete this step on each course to ensure that concrete pressure is properly distributed. Complete the corner by placing full ties centered over each deep groove on the outside of the panels. Complete all first course corners, angles, and T-walls, then build away from them to common midpoints in the walls. Leave space between midpoint panels to allow for adjustment. This seam will continue to the top of wall elevation. Once the first row is completed, pull a tape over the entire length of the wall to ensure that the building dimension is correct. Make adjustments where necessary. T-wall intersections should be installed at the same time as other corners. Begin by placing panels to form the leg of the T, lapped about 2 inches into the top of the T. Cut a 12-inch panel section and place it against one leg panel at 90 degrees. And place an inside corner bracket over the intersection. At the top of the T, place a full panel so one end aligns with the 12-inch panel already in place. Cut the remaining inside panel to butt against the T-leg and fall even with the outside panel end. Place another inside corner bracket at the intersection. Place two 90-degree outside corner brackets in overlapping fashion to connect the T-leg to the top of the T. Insert full ties as close to the intersection as possible, as well as at least 2 cut tie flanges where the brackets overlap at the top of the T. The following course will offset by 2 feet and follow the same tie pattern. Like 90-degree corners and T-wall intersection, angled corners should be installed first. First, cut the outside panels. Determine the degrees of angle and divide by 2 to obtain the bisection angle. Adjust the compound miter saw to the bisection angle. Cut a full panel, passing the cut through the center of an interlock knob. This will ensure the fit of the metal angle bracket. Cut another full panel with an opposing bisection angle, again passing the cut through the center of an interlock knob. Remove the cut interlock knob and place the opposing panels into the track to form the full angle. Adjust the metal angle bracket to fit and place over the opposing panels. Using a builder's square, transfer the outside panel end measurement to the inside track. Start the layout for the inside panel from that point. This will ensure that the panels align for tie placement. Start full tie placement as close to the apex as possible and place cut tie flanges into slots at the very tip of the apex for added reinforcement. Place a pair of panels on the second row so that the middle point of both panels line up with the vertical joint in the panels below. There should be a 24-inch offset between the end of the panels in the first row and the second rows. Do the same on both sides of the corner. Measure the spaces remaining to the corners, keeping the lap pattern identical to the bottom row. The outside panels will always be 24 inches with factory ends in the corner. The inside panels will vary in length depending on the wall cavity size, but will both be the same length if lapped identically to the outside panels. Note that there is no need to log cabin the outside corner panels. Doing so adds no strength to the walls and will throw off the layout between rows by 2 inches. Again, do not log cabin the outside panels. Place corner brackets, full ties, and tie flanges in the same manner as the first row. Corner bracket and tie placement should be the same on every row. Make note of all cut dimensions and prepare panels for the entire wall height. For instance, in an 8-foot wall, panel placement for rows 1, 3, 5, and 7 will all be identical. Panel placement for rows 2, 4, 6, and 8 will be offset by 24 inches. When pouring footings, lay out rebar dowels to match the spacing on vertical rebar in the wall. Prior to assembling the ICF wall, slip a 4-inch long piece of 1 1/4 or 1 1/2 PVC pipe over each vertical stub. This will be used later to secure vertical reinforcing bar that is dropped in from the top. Once the first course has been assembled, pre-cut rebar can now be placed. Place horizontal bar into molded rebar chairs, making sure that there's an appropriate lap where bars are spliced, usually about 40 bar diameters. Place lapped rebar in an over and under fashion to promote best concrete flow. Horizontal rebar can be tied to the plastic ties. Splices that are not in contact with one another are generally allowed by code, if the lap distance is sufficient. Through-wall penetration are made with PVC sleeves larger than the line intended to pass through the wall. Cut out EPS on either side and place the PVC sleeve through. Secure the sleeve in place with spray foam. A 16-gauge protection plate is required for plumbing lines that have less than 1.5 inches of clearance from the face of the EPS panels. Electrical boxes are cut into EPS panels with a hot knife. Quadlock recommends proprietary self-seating ICF electrical boxes from Inexo that are approved for use in USA and Canada. When using 3-inch ultra panels, plumbing lines less than 3 inches in diameter are placed into cut EPS and secured with spray foam after concrete is poured. Cut chases back to concrete and leave a minimum 1 1/2 inch clearance between cables and the face of the EPS. Wiring runs can be cut into the foam with an electric chainsaw. Continue stacking walls to the 4-foot level by repeating the panel pattern from the first and second courses, placing horizontal rebar in each level as you go. Deal with odd dimensions by creating a common seam at mid-wall and running it up the entire height of the wall. Remember to leave the common seam open to allow for adjustment in the wall length. Larger gaps are easily filled with spray foam. At each level, place a split tie as close as possible to both sides of the common seam. At the 4-foot elevation, check corners for plumb, straight, square, and level. Recheck all building dimensions. Make adjustments as necessary. Check to ensure that sleeves for through-wall penetrations are in place. Ensure that ties are placed at 12-inch on-center maximum, over all deep grooves, and over panel-to-panel joints. Ties and flanges should line up vertically, regardless of the odd or even course. Collect scrap panels and cut to 12-inch increments for reuse in the wall. Use recovered panels throughout the build. Be sure to straddle the joints with full ties. If brick finish is specified, insert brick ties at correct spacing through the exterior EPS to embed in the concrete cavity. Heavy-duty attachment points for garage doors, stair stringers, or window wells can be achieved in two ways. First, use a Simpson strong tie ICF VL bracket, which is embedded through the EPS and into the concrete cavity. Second, cut 7 1/2 inch diameter holes in the Ultra Panel EPS and remove the foam. These holes are closed off with plywood and filled with concrete during the pour. Vibrate concrete thoroughly at these locations to ensure the concrete presents at the face of the EPS panel. Remove the plywood to expose a hard point for fastening. This video deals with the installation of a typical internal ICF buckout that leaves the forming material in place after the pour. For other window installation methods like attaching windows directly to concrete or a hybrid buckout, consult the Quadlock installation manual. When the wall forms have been stacked to just over windowsill height, it's time to set up prefabricated buckouts to form window rough openings. Attach blocks to the sill to help position the buckout. Mark the center of each opening, the outside edges, and the exact sill height according to planned dimensions. Cut EPS away to sill level on both the inside and outside panels. Set the assembly into position and check for level and square. Make adjustments as necessary, then secure the buckout with 4-inch screws and windlock fasteners. Place a single vertical brace in the center or at maximum 2-foot spacing on larger openings. Do the same for horizontal braces. Brace each window opening according to instructions to follow, especially for larger openings. When the buckout is positioned and braced, continue stacking the wall. Lap the EPS panels over the wood so panels can be fastened securely with screws and windlocks after the walls have been completely stacked. Quadlock recommends the use of steel or aluminum proprietary ICF braces to ensure a safe and accurate wall installation. After the first 4 rows of panels and ties are completed, attach wood or metal strong-back braces to Quadlock tie flanges with screws. Lift each strong back about 1/4 inch off the slab or footing to allow for adjustment in wall plumb. Fasten strong backs into metal track and to every row of ties at 12 inches on center. Space vertical brace assemblies at a maximum 5 to 6 feet on center and within 3 feet of every corner. Place at least 1 vertical brace at each window opening or more for larger openings. Secure diagonal brace legs to either the ground or to the slab. Adjust walls into alignment and plumb by adjusting the diagonal leg with the turnbuckle device. Experienced ICF installers often pull the center of the wall slightly inward toward the brace assemblies. This counteracts a natural tendency for the wall to lean out. If the finished wall elevation has been set by using a ripped panel at the bottom of the wall, a full Quadlock panel can be used on the top course. Remove the interlock knobs on each panel and place panels over ties below. Insert 4 wire top ties per panel into molded slots as shown. Place inverted metal track over the panels and wire top ties, with the long leg of the track to the outside. At corners, trim the metal track so it can lap and be secured with a sheet metal screw. If a full panel has been used at the bottom of the wall, it may be necessary to rip the top panels to yield the exact wall height. Ripped panels less than 4 inches high will support themselves on tie flanges and can be poured as is. For taller ripped panels, and in order to use the track at the top of the wall, use a table saw to fashion a 1-inch deep groove in the top of each panel. The groove must be offset 2¼ inches from the outside face of the panel to fit the track. Conventional wood cleats are then used to connect the two top panels. This video will demonstrate how vertical reinforcing bar is dropped into the wall assembly after the wall is stacked. If your project requires pre-tying the rebar or other method, consult the Quadlock installation manual or consult the Quadlock technical department. Pre-cut all vertical rebar and distribute around the perimeter of the wall. Slide vertical bars down between alternating horizontal bars. Fit the bottom end of the vertical bars into pre-positioned PVC holders installed around the footing dowels. Secure with tie wire to the top horizontal bar or to Quadlock plastic ties. Ensure that all reinforcing bars are secured to minimize displacement during the concrete pour, including those surrounding door and window openings. Install a string line around the top course of panels, spaced away from the panels by a common measurement. Stretch the string line tightly and align walls by measuring the gap between string and panels with a spacing block, making adjustments with bracing turnbuckles as needed. Recheck wall dimensions and plumb at all corners. Prior to securing common seams, check corners for plumb and make final adjustments. Close off any remaining gap between panels with low expansion spray foam. Cut 24-inch long straps from plywood or 1x4 lumber. Screw wood straps to plastic ties across the seam with 2 screws on each side of the seam. Place straps on every row and on both sides of the wall. If using Simpson ICF VL brackets to create support for floor ledgers, snap elevation lines to show the ledger position. Mark the bracket legs and cut slots into the EPS, then insert the legs of the ICF VL bracket into the wall cavity. The face of the bracket must be flush with the face of the EPS panel. If a ledger board is to be attached with anchor bolts, cut out minimum 7.5-inch diameter holes, round, square, or rectangular, on a predetermined spacing. Using that same layout, drill the ledger and pre-mount anchor bolts securely in the ledger board. Using the elevation lines, mount the ledger board on the wall with the anchor bolts centered on the pre-cut holes in EPS panels. Ensure that the elevation stays stable by supporting the ledger with 2 bivertical braces attached to the tie flanges. If the wall terminates with a sill plate on top, anchor bolts will either be pre-positioned and cast in concrete or inserted immediately after the concrete pour. Calculate concrete usage on your project by multiplying the length times height of your ICF walls, then deducting window and door areas. Apply standard coverage factors for your wall cavity width. Contact the ready-mix supplier and request an ICF mix with the minimum 6-inch slump and compressive strength according to the specifications for your plan. 4쿼드락 recommends a 3/8-inch maximum aggregate size to promote better flow and consolidation. Order pumping equipment with hose reduced to a 3-inch diameter at the end. Truck pours and suspended hoppers are the least preferred placement options. Have a mechanical vibrator on site, regardless of other means of consolidation that you may plan to use, in the event that consolidation doesn't proceed as planned. Confirm that the concrete compressive strength ordered meets or exceeds the building plan specifications. Maximum concrete aggregate size should be confirmed at 3/8 of an inch. Have pumping equipment arrive at site with the preferred 3-inch diameter hose. Concrete should be ordered at a low slump of 3 to 4 inches with water, then taken to a minimum 6-inch slump with plasticizer prior to pour. Space concrete truck delivery to allow time for placement and initial set of the first lift. Have working vibrators and adequate extension cords in place and ready. Make pour day a safe and efficient one with good preparation and attention to detail. Refer to the 4쿼드락 Basic Installation Guide for this list and a checklist of other important items. Assign crew members to handle the pump, place concrete, run the vibrator, spot the bottom of wall for pour height and possible issues, and to check for quality control. Be sure that anchor bolts and other materials are easily available, as well as the concrete vibrator, water for cleaning, and personal protection equipment. Have plywood and lumber or metal bracing available to repair problem areas. Place 2 to 3 feet maximum on the first lift around the entire building. Successive lifts can be 3 to 4 feet in height. Vibrate mechanically using a pencil vibrator with a maximum diameter of 1 1/4 inches. Insert through each successive lift elevation and avoid over-vibration. Vibrate or shake rebar to clear buildup of concrete. Pay close attention to consolidation around doors and windows. Check for plumb, straight, square, and level. Realign walls with adjustable bracing. To make minor adjustments to elevation, Raise track slightly and pin to foam panels. Screed away excess concrete and trowel smooth. Set anchor bolts at specified centers. Finally, recheck and adjust alignment of walls. This video is a summary of the most important quality control checks that must be done prior to building and then pouring concrete in your ICF walls. Ensure that building lines are snapped on footings and that they take into account the thickness of the ICF foam panel. Confirm the exact wall elevation. Ensure that adequate bracing and scaffolding is available to safely build to that height. Check that metal track is securely fastened to footings or slabs around the entire perimeter. Check spacing of quad lock full ties at 12 inches on center, both horizontally and vertically throughout the wall. Confirm that walls are properly aligned, plumb, and level. Check the building for square using cross measurements of the largest rectangle areas available. Check the layout of vertical bracing strongbacks placed at maximum 6-foot intervals. Be certain that each strongback is fastened to each tie flange at 12 inches on center with fasteners specified by the brace manufacturer. After corners are checked for plumb, secure common seams with plywood cleats and spray foam remaining gaps. Recheck window and door rough opening sizes and elevations. Be sure to account for floor finishes at door openings. Note positioning of electrical and plumbing supply points protected with sleeves through the walls. Plan and pre-build window and door buckouts. Openings should be internally braced both horizontally and vertically. Recheck window and door openings for plumb, square, and level. Window sills should be open to receive concrete and consolidation with a vibrator. Sills should be poured first. Confirm window and door lintel dimensions and reinforcement. Ensure that rebar is secured against movement during the pour. Secure panels to internal buckouts that will be left in the wall with screws and windlocks on both sides of the wall.